Assalamualaikum and hello. In this video, I'm going to continue with isomerism. Isomerism defines as compounds with same molecular formula but different arrangement of atoms. This is where you are going to apply how you want to draw the structure of molecule with the same molecular formula in different arrangement of their atoms. So there are two categories of isomer. The first one is constitutional isomers, or the other name is structural isomer, where the compounds with the same molecular formula but different structural formula. The next one we got stereoisomerism, where the examples of them are cis-trans isomers and enantiomers. The next one, we are going to continue with the structural isomers. There are three examples of them. The first one is chain isomer. For chain isomerism, it differs in the structure of carbon chain, where the carbon chain will be in its longest chain or in the shorter one. The next one, we will have positional isomerism, where it differs in position of functional group. So the tips that you have to take a look is the functional group. The next one, functional group isomerism, where you have the same molecular formula for the compounds but different functional group. We will focus them one by one. Now, we are going to start with the first example, C5H12 for chain isomer. I'm going to start by drawing the longest carbon chain based on this molecular formula. So what I have here is C5H12. So the longest carbon chain is 5. So I'm going to draw 1 carbon, 2 carbon, 3, 4, and 5. And the next of it, I'm going to fill in each carbon with 4 covalent bonds. So I'm going to give the numbering first so that you can see it very clear. 5 carbon chains. And then what's next? 4 covalent bonds for each of them. 2 more left, 2 more left, 2 more left, and 3 more left. And the next of it, you are going to attach all of those covalent bonds to hydrogen atoms. So you got 3 here, 5, 7, 9, 10, 11, 12. So this is going to be my first isomer A. I'm going to resize this one so that you can have more space. Now let's continue with the next isomer. The tips that you have to understand, you are going to shorten the carbon chain by making branches using substituents. So I'm going to shorten from 5 to 4. So please shorten the chain one by one. So now my second structure with 4 carbon chain. I got 4 carbon chain here. I give the number 1, 2, 3, and 4. And what's next? I'm going to put the 5th carbon at either carbon 2 or carbon 3. I'm not going to put at carbon 1 or carbon 4 because it's going to be the same as structure A. So of course, I'm going to put at either carbon 2 or carbon 3. Let's try to put one last carbon at carbon 2. So this is going to be my 5th carbon. And what's next? Fill in all carbons with 4 covalent bonds. So let's start with first carbon. I got 3 here. And I got 1 here. 2. And I got 3 here. And I got 3 here as well. And the rest of it will be attached to hydrogen. Make sure your number of hydrogen is 12. So 3, 6, 7, 8, 9, 10, 11, 12. So you got the second isomer with different arrangement of carbon chains, structure B. I'm going to resize this one so that you can compare between these two structures, the difference of their arrangement when drawing the isomer. Now, let's continue with the next one. I'm going to shorten my carbon chain from 4 into 3. So, my longest carbon chain right now is 3. So, 1, 2, 3. Give the numbering for them. And you got 2 more left for your carbon. I'm going to put it at the carbon in the middle, which is carbon number 2. So, you are going to put both of carbon atoms left at this same carbon. One here and one here. So, this is going to be carbon number 4 and carbon number 5. And the rest of the carbon, you are going to add up 4 covalent bonds. So same goes for all of them. And now each of the bonds must be attached to hydrogen atoms. So 3 here, and then 6, and then you got 9, and you got 12. So this is my third isomer. I'm going to label them as isomer C. So this is where I'm going to resize so that you can see the difference of the structure. What can you see here? The longest carbon chain for structure A is 5. The longest carbon chain for structure B is 4. And the longest carbon chain for structure C is 3. And for structure A, there is no substituents because you are not making any branches. But for structure B, you got one substituent, CH3 group. So this is going to be your first branches. The next one, you are going to take a look at the structure number 3. So this is structure C, where you got two substituents here. So you got two substituents with CH2 group here and there. So this is how you want to show different arrangement of atoms in chain isomer. Now, I'm going to continue with positional isomer. For positional isomer, the first tip that you have to know that it must contain functional group. If there is no functional group, you cannot say it can form positional isomer. Let's try to identify where is the functional group in this molecular formula. C3H7Cl, I got Cl as my functional group. This is halogen. How I'm going to continue? I'm going to start with my carbon chain with 3 carbon atoms. So let's start with 3 carbon and give the number for each of them. And after that, I'm going to put my functional group, halogen, at the first carbon. So this is going to be attached to Cl. And the next one, the rest of carbon must have 4 single bonds. And it must attach to hydrogen atoms, maximum 7. So let's try calculate with me whether it's enough or not. 1, 2, 3, 4, 5, 6, 7. So this is going to be my first structure for isomer. I'm going to draw and label it as 1 Roman. Now, let's continue with the next structure. As you see from here, this is the structure of isomer with the position of your functional group halogen at carbon number 1. Now, can I change the position of functional group at another carbon? So I can change this one at position number 2. So I'm going to replace the position with the new drawing. Draw with the 3 carbon chain, and after that you got each of the carbons with 4 covalent bonds, And carbon number 2 here will has Cl group attached to it right now. So this is going to be my halogens. What's next? The rest of the bonds will be attached to hydrogen. So I'm going to draw it like this one with 7 hydrogens. And as you see here, this will be the second structure for positional isomer of C3H7Cl. As you see from here, what differs only the position of functional group. So please be careful. If you want to do the positional isomer, the first thing first that you have to check whether that molecular formula contains functional group or not. Let's go with the last isomer, which is functional group isomers. The tips that you have to know here, you have to memorize the coupling. For example, you got different classes of compounds. You got each of them one coupling. So this alcohol and ether will be coupled with this same general formula. Same goes for aldehyde and ketone with same general formula. Carboxylic acid and ester will be coupled together with the same general formula, and also alkene and cycloalkane with the same general formula. So for example, I have here is C2H6O. As you see from here, your general formula is N equals to 2. So when N equals to 2, it means that this is going to be your first general formula for carbon. And the next of it, you will have H2N plus 2, and then followed by O. When N equals to 2, you add up in the formula for this one, you will get C2H6O. And if you take a look at this general formula, this one is referring to the coupling for alcohol and ether. So I'm going to show class of compound alcohol and ether based on this molecular formula. So of course, you have to memorize the structure of functional group. So let's try with alcohol first. I'm going to draw alcohol with C2H6O. So I got 2 carbon chain, 1, 2, and after that you got 4 covalent bonds, and one of it will attach to OH group. So I'm going to draw here as OH group, and you have to make sure you got 6 hydrogen attached to the rest of the bonds. But right now you got 1 hydrogen already, so 5 more left with 2, 3, 4, 5, and 6. So this is going to be the first structure for functional group isomer alcohol, label below 8. And the next one, I'm going to draw to you with its couple, which is ether. So how you want to draw ether? Ether, the functional group will be C bonded to O bonded to C. And this is the functional group for ether. And the rest of the C atoms will have 4 single covalent bonds. And what's next? You are going to fill in with 6 hydrogen. 1, 2, 3, 4, 5, 6. So this is the structure for functional group isomer of C2H6O by using ether, by drawing ether. So you got 2 structures here. So what can I conclude from functional group isomer? You have to memorize the coupling. If you don't remember the general formula, it's fine. But make sure you can detect the functional group exists in the molecular formula based on the question given. I leave exercise 7 for you to complete. And for the next video, we are going to continue in the next part 3. I'll see you in the next one. Thanks for watching. Bye.